Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Last lecture we have seen how to find the general solution for exact differential equation. This lecture we are going to see how to reduce to non-exact to exact and how to find the general solution. So these are to reduce from non-exact to exact, we require integrating factor. So to find this integrating factor, we are having different methods. In this lecture, let us see methods 1 and 2, how to reduce from exact, non-exact to exact and problems on it. So let us define integrating factor first. mdx plus ndy equal to 0 is not an exact. For all the differential equations, it's not compulsory to satisfy the condition dou m by dou y equal to dou n by dou x. If this condition is satisfied, it is exact. Otherwise, we call it as non-exact differential equation. So any differential equation which is not satisfying this condition is a non-exact differential equation. For that, we have to introduce a term integrating factor. If you multiply this function, integrating factor is a function. If you multiply this function with the given equation, then this will be converted to exact differential equation. Integrating factor is some function of x and y. If we multiply this term with the given equation, then that is converted to exact differential equation. So there are many methods to find this integrating factor. So first let us see the method 1. This method 1 is called as method of inspection. So we need to remember these formulas so that by seeing the question, we have to apply these formulas. You know, derivative of xy is uv dash x dy plus y dx, derivative of y by x dy minus y dx by x square. Like that, you have to remember all these formulas so that we can do the problem by method of inspection easily, right? Let us solve this one problem. Solve this x dx plus y dy equal to x dy minus y dx by x square plus y square. You recall, do you see any terms x dx plus y dy, x dx plus y dy right hand side for all these formulas, x dx plus y dy. In RHS we have this. So this can be written as derivative of x square plus y square by 2. So derivative of x square plus y square by 2. Right side term can be written as derivative of tan inverse y by x. We have to remember these formulas. Then only we can solve the problem easily. So now both sides we integrate. So integral derivative get cancelled. So we get x square plus y square by 2. Derivative integration get cancelled. So we have only this term tan inverse y by x plus c. So this is the required solution for the differential equation. So let us solve this x dy minus y dx equal to xy square dx. So first you write the equation in the form of mdx plus ndy equal to 0. Then check whether the equation is exact or not. If it is not exact, how to find the general solution? First by method 1. So first of all, you divide this equation with y square. So x dy minus y dx by y square. Both sides you are dividing with y square. So x dx by y square. So we get this, or this equation can be written as x dx plus, if you take minus common, this can be written as y dx minus x dy by y square. Because denominator we have y square, so to apply the formula, this can be written as derivative of x by y. Y dx minus x dy by y square can be written as derivative of x by y. That's why we have taken minus common here. So minus of minus is plus. Now integrating, x dx integration is x square by 2 plus derivative of x by y is derivative integration get cancelled. This, so x square by 2 plus x by y equal to c. This is the required solution. Now let us see the second method to find the integrating factor. How to find this by method 2. What is method 2 is, if mdx plus ndy equal to 0 is a homogeneous differential equation and this mx plus ny not equal to 0, then we say that 1 by mx plus ny is an integrating factor of mdx plus ndy equal to 0. So let us solve this example. Solve x square y dx minus x cube plus y cube into dy equal to 0. You compare this with mdx plus ndy equal to 0. So m is x square y, n minus x cube minus y cube. So differentiate m with respect to y. So x square is constant, I am writing as it is, y derivative 1. So dou m by dou y is x square. Next, dou n by dou x is minus 3x square. These two are not equal. So dou m by dou y is not equal to dou n by dou x. So the given equation is not an exact. Now once it is not exact, by trial and error method we go for method 1. We cannot apply method 1 for this equation. Now coming to method 2. What is method 2? To apply this method 2, 1 by mx plus ny integrating factor means it should be homogeneous. Now let us check this differential equation whether it is homogeneous or not. Homogeneous means power of x and y should be equal in every term. Here you can see power of x is 2 and power of y is 1. Both, if you add 3, right? Here also power 3, here also power 3. So power of every term is 3. So we call the homogeneous differential equation. Once it is homogeneous equation, what can you confirm? The integrating factor as 1 by mx plus ny. This is the integrating factor. So you multiply m with x and n with y, add these two terms mx plus ny. So 1 by mx plus ny is minus 1 by y power 4. Okay, we got the integrating factor. What next? Once we get the integrating factor, we multiply the integrating factor with the given equation so that this will be converted into exact differential equation. So after multiplying with the minus 1 by y power 4, this is the equation we get. Now this is of the form again m1 dx plus n1 dy equal to 0. So after multiplying, let us check whether the given equation is converted into exact or not. So let us m1 minus x square by y cube and dy coefficient, let us take it as n1. So dou m1 by dou y is 3x square by y power 4. This is same as dou n1 by dou x. So both are equal. So this equation 2 is exact differential equation. Once it is exact differential equation, we know how to find the general solution, right? So this is the formula to find the general solution. Integral m1 dx, don't write integral m dx, because this equation m1 dx plus n1 dy equal to 0 is exact. So while writing the formula integral m1 dx, make sure that y is treated as constant plus terms independent of x in n1, not in n1, right? So integration of minus x square by y cube dx, where y is constant, plus integral 1 by y dy equal to c. So here y is constant, so 1 by y cube is constant, integration of x square dx, this is the first term. So what is the integration of x square? X cube by 3. So we get minus x cube by 3y cube, plus what is integration of 1 by y? This is log mod y equal to c. So this is the general solution for the given differential equation. Let us solve one more problem based on this. Solve y square dx plus x square minus xy minus y square dy equal to 0. Again write down the equation in the form of m dx plus n dy equal to 0. If the equation is not in this form, first write down the equation in the standard form, which is mdx plus ndy equal to 0, and check whether the given equation is exact or not. That is dou m by dou y equal to dou n by dou x. So here m is y square, n is x square minus xy minus y square. So dou m by dou y we got it as 2y. Dou n by dou x is 2x minus y. Both are not equal. So dou m by dou y not equal to dou n by dou x. So we say that the given differential equation is non-exact differential equation. Once it is not exact, we have to find the integrating factor. So here also you can see the power of every term. Power is 2, here power is 2, power of x and y is 2, here power of y is 2. Power of each and every term is same. So we call it as the given equation is homogeneous. If the equation is homogeneous and it is not exact, what is the integrating factor? We can see 1 by mx plus ny. So 1 by y into x square minus y square is the integrating factor. Once we get the integrating factor, we have to multiply this with the given equation, right? So after multiplying, let it be equation 2. Now dx coefficient, let us take it as m1, dy coefficient, let us take it as n1. So we have to check now this equation is exact or not. That means how to check the condition? Dou m1 by dou y should be equal to dou n1 by dou x. Let us check this. So dou m1 by dou y, apply u by v rule. So we get, what is u by v? d by dx of u by v, that is v u dash minus u v dash by v square. By using that, we get dou m1 by dou y is x square plus y square by x square minus y square whole square. Similarly, dou n1 by dou x, as if you multiply again by u by v, we get this, both are equal. So we say that this equation 2 is exact. Once it is exact, we know how to find the general solution. So again, write down the formula for exactness. Integration of y by x square minus y square dx plus terms independent of x in n1. Here what is n1? This is n1. I don't want x terms, so purely only 1 by y is there, dy equal to c, right? So n1 is 1 by y after excluding x terms. Now I want this integration. Here y is constant, so take it outside. Integration of 1 by x square minus y square. If you are in confusing, let us write in place of y a x square minus a square dx. So what is the formula for 1 by x square minus a square? 1 by 2a log mod x minus a by x plus a, right? After writing this, now replace a with y. Here in place of a, just write down y so that you won't get confused. So here 1 by 2y log mod x minus y by x plus y. This y and y get cancelled. So we get 1 by 2 log x minus y by x plus y. That is log of x minus y by x plus y power 1 by 2 plus log mod y equal to log c. Log a plus log b can be written as log ab. So this can be written as log x minus y by x plus y whole power 1 by 2 into y is equal to log c. So both sides log get cancelled. We get this. This in turn can be written as like this. This is the general solution for the given differential equation. So this is how we find the general solution by using integrating factor. Next lecture we are going to see method 3, method 4 and 5 for the integrating factor for non-exact differential equation. Thank you.